In an ideal world, we would have gone water, wine, clear. But we didn't. But the quite interesting thing is the second one, where when they added them together, it didn't immediately change colour. It took a bit of time. So that's an area that I want to play around with, because I think it's quite enjoyable. To, one, you get colour change to show what's happening, and two, you get quite interesting things happening. So here, instead of A going to B, which was what happens normally, you know, you add two chemicals, immediately colour change. Here, A goes to B, which changes colour, but there's another reagent in there that actually reacts with B and gets rid of the colour. When all that reagent is used up, you can then see the colour again. Okay? So if we had 100 atoms of A and 10 atoms of C in this mixture, we would go, like, for the first 10 molecules, I've said molecules, that's much better word. 10 molecules of A goes through, reacts with C, we don't see any colour, because it's reacted in non-clear. As soon as the 11th molecule comes around, we begin to see the colour again. And that's what's causing this delay. So I want to play with that a bit more. So I've made some that have got a bit more of an interesting colour change. So I've got to make sure I've got A and B plot. So that's good. And C, we're going to add, which is actually B in this case. Okay. So now we've got A, B, and C in here, and it should be reacting away. And very soon, hopefully, we should see a nice colour change develop. I forgot how many seconds I made this run for. Might be 2 minutes, might be 10 minutes or something. But what's happening is A is going to B, and B is reacting with C, and it's remaining colourless. So keep your eye on that, and I want people just to tell me when it changes colour. Keep my fingers crossed that it will. Okay. And I quite like audience participation in these things. So, see? So A plus B plus C, where C reacts with B and removes the colour, we get this delay. So now I've got a general question. You may have noticed I've got 3 plus here. Okay. Little one, medium-sized one, and large. And it's the same reaction. A plus B generates a colour, bit of C, removes the colour until all C has been used up. This one, I'm going to prepare, better take the cling film off. There's one reagent I have to add myself, but I would like 3 volunteers to help with this. And I want somebody who's quite small. You volunteered there. You're on the quite small side. Here's your small bit. Somebody average size. All right. We'll go sort of like, there you go, average size. Yeah, come down. Have we got anybody who's super tall? Huge. All right. Yeah, we've got one from your school. Tall one. Yeah, you come on down. You're stuck. Okay. Right, I can see it. So the guy who was catching a balloon earlier on, he was quite a tall lad. Okay, all the being small. If you come down, you can do that. Okay. We've got glasses. Glasses and gloves. If you set these people up whilst I just prepare this. Okay. Okay. No, because they're all in. Right. We'll better get some safety gear for it. So if you just stand there and... Okay. Right, there you go. 1 for the large, 1 for the medium, and some snazzy ones for the small. Okay, you actually become small now. Okay. When you're down here. Alright? Thank you. Your medium, and there's some big glasses for the large. Okay? Alright, so let me do this. And what I'm thinking is these... It's quite an interesting... What's that? This one is 5 times the size of that one. And this one, if I can get rid of the clinker, is 10 times the size of that one. So there's 10 times as much A in here as there is in the first one. Have we got glasses sorted? Have you got any spare glasses?
I got some.
All right, thanks, Graham. The efficient technician helps me out here.
Yeah, I'm really something good.
Okay. And now we're mixing them up. In that grand scheme of things, we've got, in here, we've got A and C. Okay? Now, small, go there. Okay? Get ready. Medium, pick up that one. Large, go that way. And all I want you to do is remove the top and pour the thing in when I give it a countdown. So I want all these to start at the same time. Okay? Right. So you can slow that down a bit. And then when it's poured, just sort of move over to the back whilst we interrogate the rest of the audience. Right. I'll give a countdown of 3, 2, 1 and then go. Okay? 3, 2, 1, go. And pour it in. Alright, okay. Now if you just move a bit further now. The question I want to ask the audience is, this one is 5 times as big as that, this one's 10 times as big as that. Say this one takes 50 seconds, how long is this one going to take? How long is this one going to take? Well, show of hands, is this going to take longer to react than this one? How many people this one will take longer? Okay? Okay? Right. Go on, a bit more show of hands, a bit more confidence, right? It's going to take longer, it's bigger, it's going to take longer. What about this one? Slightly less long and everything. Okay? Right? So now we've got to keep our eyes on what's happening. Does anybody think anything different? Okay? They react at the same time. Okay? So we've got a difference of opinion. Some people think it's going to take longer, people think it's going to react at the same time. When faced with a difference of opinion, you would set up this experiment and run it yourself. So, you know, somebody's got 2 different views, we'd run it and we'd see what happens. I've got my fingers crossed that it is going to actually work. And I forgot how long I set it to take. If this one took 50 seconds, if this one's taken a lot longer, it might be 100 seconds to go. 1, 2, 3. Right? And there's some subtlety there. It didn't take 5 times as long to react. That's certain. It took a little bit longer to react. And it didn't take 10 times as long to react. It's only a small amount of time. Okay? But in reality, it takes the same amount of time to react. And the person who said the same amount of time to react. Because this is like a very small bit of fat. It's got exactly the same concentrations. It's 10 times more of the amount, but the concentrations are the same. And it's concentration that's important when you think about the speed of a reaction. Anybody got any idea why it went 1, 2, 3? Right? Somebody at the back, okay? Perfectly right. You may have noticed it's about the same amount of time as it took to pour the last bit in. There was only 50 ml going in here, it's straight in, reacting. 125, a bit longer, 250, a bit longer. So one of the concepts we want to get across is concentration is what's important when you're thinking about how quick a reaction goes. The amount of substance is just generally important in terms of the total amount of energy coming away. And what this means is I can sit in my lab with a test tube, make an observation, and apply it to a much larger industrial scale. So those small observations you make in the laboratory can be applied to much bigger reaction systems. This is really important to get across at the moment.
Okay,
Brilliant. Very well done, the volunteers. Put up the glasses back, because I think our person... Okay. And who, congratulations, one said it was all the same. You was a minority on that audience, you know, or you was the only one with the confidence to shout.